Hi, it's Reese from Reese Teaches Programming, and welcome to my last video on testing in our section on DevOps and testing. If you have been hanging with me through, I think 8 or 9 videos now talking about all of the different types of testing we have to think about in our QA pipelines as we get into DevOps, hey, congrats, because I know this is so much information. So in our final video in this section, I'm talking about security testing, which I think is one of the most critical aspects of a modern DevOps pipeline. And I'll tell you, as a, cybersecurity enthusiast, I can't call myself a professional, although I would very much like to. It irks me that security is all the way down here at the end. And that sometimes we don't think about security testing at all, or that somehow that's like a separate department. And so as software developers, as QA people, as DevOps people, security should always be in the forefront of our mind. So while functional testing checks if our application works, security testing asks, can someone break it? So in this video, we're going to talk about, what it is, why it matters, what types exist, and how we can integrate it into our workflow. So let's start with the what and the why. What is security testing? So it's the process of finding vulnerabilities in your code or in your configurations and dependencies before attackers do. And these can be a wide range of security problems. Think of it like locking your doors at night, checking your windows, setting your alarm before you invite guests into your house. We don't want to have these problems and then someone breaks in and we didn't know about it. It's important. We hear about data breaches all the time. Unauthorized access, compliance violations, where attackers go in and they export a bunch of data and then they leak it. These are all very real risks, and they're often very preventable if we understand what it is that we're looking for. So if you do work in an industry that requires compliance with different types of data handling laws or rules, and where you might even have to disclose a breach like this that would happen, that's critical. We want to make sure that we're security testing so we just don't ever have to get into that situation. So tools. Some of the tools that we can use for security testing to help us find and fix vulnerabilities, like always, really depends on our stack and the server architecture that we're using. So tools like OWASP, a popular open source tool that gives us dynamic analysis of our code base. We've got tools that look at code, dependencies, containers, security linters. And if you're not familiar with that term, a linter is a tool that looks at your source code, it flags potential errors or bugs or stylistic issues, and it can really help developers improve code quality. And dependency checking. This has become more and more of an issue, and I'll date myself here by saying I'm an old developer who didn't used to have so many dang dependencies in my projects, but nowadays, in order to get anything done, we have a lot of third-party packages. So we often are putting our fate into the hands of third-party developers, and when they have a problem with their package and there's a known vulnerability, we have to decide what we want to do with that. Do we keep using that package? We don't have the ability to fix third-party code. We just have to decide how we can mitigate the issue on our end, or, can we stop using that package and find a replacement, which can sometimes be impossible. So there's a lot of things that go into choosing a tool and then how we integrate it into our CI/CD pipelines. So we talked, what is security testing? We're trying to identify and fix vulnerabilities, but what are some goals, right? The main goal of security testing, the main goals, because there's 5 of them. So we want to protect sensitive data. That's things like user credentials, that personally identifiable info, right? The PII. We don't want anyone to be able to get that kind of information out of our system and then leak it. We want to prevent unauthorized access or privilege escalation that might let users into parts of the system that they shouldn't be allowed. We want to stop common attacks like cross-site scripting, SQL injection, cross-site request forgery, and if you're not familiar with these terms, definitely dig in more on some security topics to learn more about just like what is cross-site scripting and how can I prevent it. You want to ensure compliance with regulations. So you might be under the umbrella of the GDPR or HIPAA. So you definitely want to make sure you're following any rules or regulations or laws about the data that you handle. And then we always talk about shifting security left. So that means as we think about our development life cycle and this roadmap of where things happen, we want to shift security to the left into development, and it's not something that we just talk about in production. We want to have security always in the forefront of our mind, because if we're not building secure software kind of like from the ground up, right, by design, we're not going to be able to stop the problems that are going to leak into production because we just weren't thinking about it. So just like we saw with performance testing, there are some different types of security testing, like some sub-testing approaches that we can take depending on some of the different things that we might be looking for. And some of these different tests, they will surface different types of security problems. So the first one is static analysis. This scans your source code before it runs. I talked about that linter. So it actually looks through your code base and identifies maybe common problems. Maybe you didn't protect this variable. Maybe you didn't use a parameter in your SQL query, but it's going to look for those things and then highlight those so you can fix them right there in the source code. Then dynamic analysis scans the running application, looking for things like open ports that shouldn't be there, looking for hooks in the application process, looking for elevation of permissions. So it's going to look at all of those things that are happening while the application is running that someone might take advantage of. Dependency scanning is going to check through those libraries that you're using, looking for known security events and highlighting those so that you can make that decision about what to do with third-party libraries. Secret scanning is going to look through your code for things that really shouldn't be there, like API keys, tokens, authentication credentials. We have lots of different ways, especially these days, to keep our secrets safe in our development environment and in production that we definitely shouldn't be putting those things in our code or in our code base. Infrastructure scanning is going to look at your servers, containers, and cloud settings to make sure that the places where your code lives and where you're deploying to don't have vulnerabilities. Again, open ports, how your configuration works with your containers, those cloud settings, who can access your application, what endpoints are available, and should those be available maybe to uncredentialed or untokened users. So checking those kinds of things are important. And then penetration testing is the process of simulating a real-world attack. There's software that can automate this process, or a security professional who is versed in penetration testing can actually perform a manual check. So they'll go through various ways that they know how to infiltrate a system and try to gain access to areas of your application that they shouldn't, or get data that they shouldn't, or impersonate a user, impersonate an admin, and then be able to provide you with a report of those activities so that you can see those vulnerabilities that they found and then take steps to mitigate those. So all of these different types of our security testing kind of play a different role in covering our system's attack surface to make sure we are plugging all of the holes at all levels. So let's look at some of the tools that are available, again, by language, by stack. So for .NET, tools like SNCC, the .NET Security Audit, DevSkim, those are great. Node.js, NPM Audit will tell you about all of the packages that and dependencies that you have that have open security warnings. Using ESLint is another good option there. Python, there's Bandit, Safety, Pylint, And then general security, OWASP, there's the Burp Suite, Trivy, Chekhov. There are these like general suites that will help kind of fit your environment. So no matter what stack you're using, there is a tool that fits your workflow. And again, no excuse for not checking out the security of your application. So where does it fit? Security in our DevOps pipeline. And you sometimes hear this term, right? So security belongs in every part of your DevOps pipeline, which is the foundation of the term DevSecOps. So at code commit, we want to run our static scans, our dependency scans, and secret scans. Then in the CI pipeline, we run our static and our dynamic tools to check on those pull requests and pushes to see how the data is moving and is that secure, sometimes also known as data in transit. During the build, we want to validate that dependencies and configurations are secure in the way that data moves between those. At deployment, we want to look at container images and infrastructure, databases, things like that. And then in production, we monitor our logs, we detect intrusions, we block suspicious traffic. There's a lot going on, right? Security is not just one step, and it should be part of every step to make sure that we are setting ourselves up for a secure environment that attackers, bots, whatever, can't take advantage of. So if you're new to security, or you're new to the idea of security and application development especially, maybe you're not sure what to monitor for or what to block. So think about hard-coded secrets or credentials in your code base. Again, we should not have API keys, tokens, things like that in our code base. You just never know when someone's going to be able to gain access to that and leak those. We definitely don't want them accidentally being exposed through the user interface or in our database. Outdated dependencies. So checking for those to make sure we don't have any known vulnerabilities from third-party packages, checking those, all of the different packages that you're using can surface those up. Looking for injection flaws like SQL or command injection, and then working through some steps to mitigate those. Looking for misconfigured cloud resources, like are you using an S3 bucket that's public? You could be putting data in there that maybe puts your user information at risk. Looking for open ports, looking for unsecured endpoints, looking for ways that attackers could access parts of the application they really shouldn't, or parts of the application that let them into more data that then gets us into trouble. And then looking for things like missing HTTPS or key headers like content security policy, just to make sure that the browser isn't going to accidentally serve our page in an unsecure way and our application is set up to use all of that security. So these are the most common gaps that attackers look for first, and they're very easy for you to then spot using these tools and mitigate so you don't have to worry about it. So what are some best practices, right? Best practices for embedding security into our development workflow include that idea of shifting left. Start security testing early at the code level. Help your developers learn how to write code securely. What are these openings that they could be creating inside of the code so that they can just write their code better and it's secure from the start. Automation. I talk about automation a lot because we want to integrate our security tools and our checks into our CI/CD pipeline, just like your unit tests, and then they're not optional. Everyone has to run them. Fix early in the dev cycle. It's a lot cheaper to patch a development bug than clean up a production breach. And those are orders of magnitude of differences when it comes to easy. Use threat modeling. So if you can think like an attacker to identify weak spots, that's great. If not, invest in a security professional's analysis so that you can get that report and they will identify those things for you, and then you know exactly what to work on. Keep your dependencies updated. Something like Dependabot can go and manage that for you. And then, never hard code secrets. And I say this a lot because it's something that you see. You can use secret managers, you can use GitHub Actions, you can use Azure Key Vault. There's a lot of different ways that we can keep our secrets safe. And, there are bots that just roam around on GitHub looking at public repos, trying to pull API keys and credentials and things out. And man, before you know it, you're compromised. And all it took was just one kind of messy check-in, and it could have been avoided. Absolutely could have been avoided. So I'm going to list in here the OWASP Top 10. If you're not familiar with the OWASP, this is the Open Worldwide Application Security Project. They are, an open source kind of online community that produces a lot of free content and methodologies and documentation to help software developers learn more about application security. And they have a list of their top 10 vulnerabilities that you can see here. So those are injection, right? Like SQL and OS injection, making sure you're using things like parameterized queries. That's going to keep attackers out of your data. Broken authentication, sensitive data exposure, insecure design, security misconfiguration, vulnerable third-party components, broken access control, cross-site scripting, insecure deserialization, and server-side request forgery. Now, if you're not familiar with any of these terms, I strongly encourage you to go dig in, right? Find a video, go out to OWASP, read an article. These risks are real and preventable with the right practices. So, we've talked about a lot, and you've made it to the end of our testing set. So, to wrap it up, security testing is not optional. If you are not testing for security, you are in for a world of hurt when your application gets out there to the real world. Our application security, really, it's how we build trust with users. Users are getting these data breach notifications and hearing about these things in the news and getting these apology emails all the time, and it damages your brand and your customer trust. So protecting data, avoiding costly disasters, it all comes down to starting early and automating everything. We should never assume our code is safe. We have to test it to prove it. So thank you so much for joining me for this video, for this section. We're going to switch gears a little bit and start digging into some practical application of these testing ideas and setting up our pipeline and getting ready to, start writing our tests now that we know all about what they are and where they go in our pipeline workflow. So thank you so much for hanging out and sticking with my video series. Let me know if you have any questions in the comments, and I'll see you next time.